Adhere Gear Prototype Program 2018. Working on the slide. We have okay. I'll use this as a good model. So this one, here's the slide. Slides in, slides out. So the issue we have is that right there. You're hiking. How do you prevent it from coming out? I don't know. Haven't figured it out yet. The other thing is, how do you make it so it's a smooth transaction, right? Something that's pleasant, enjoyable, easy, effortless. You know, all those kind of adjectives are important when putting together something like this. So what we've done is we've analyzed, we did a lot of design work on the computer, failed a bunch of times. It came up with some great ideas, but I overcomplicated it. So we decided to study Windows, and they have screens on them, and they typically have some sort of track system, or you know, there's a lot of thought's gone into how Windows work, especially when it comes to waterproofing and stuff. So we took basic screens. They have a nice shape, you can see. And what we're doing is we're taking two of them, we're cutting them at angles. We sand it and bevel them down real smooth so they're no longer really a hazard or sharp. And what we want to do is we want to take each one of these and we want to sandwich them together so that they slide, interlocking. What that allows us to do, this is our prototype we worked with, so we got two angled slabs which represent the slide out feature, and we glued the track system on either end, and we put another one in the middle just as spacer infrastructure, because this is like 0.063 millimeter thick PVC. So here's a good demonstration. Let's just do it for this side. So there it is, sliding. Effortless. So it's pretty decent. The only thing that we've run into is how do you make it so it stops, right? Going back to this, we need it to be a 3-inch max distance that it travels before it somehow locks itself. So we want it to stop like somewhere right there and somehow lock itself, and then we also wanted to do some sort of ratcheting effect, or like multiple options where like you can stop it almost anywhere and somehow it'll always lock into place, and then it has a max and then like a min. Not easy to figure out, but I think we're on the right track. No pun intended. At least with this guy, because we're able to have this mounted. And what's good is that we don't actually need the second track. We can do something like this. This is, I think this is like 1/4-inch PVC. Here's the same track, and it fits in there nicely. And then it can just slide along that pretty easily, right? It holds itself pretty good. So the theory is when you have your core pod, you would have one of these tracks mounted onto each side. So one there, one there, one on each corner. So that you would slide the entire thing in, almost for maintenance. You want to be able to take it out so you can do some maintenance on it. There's going to be some components in here. But also for the assembly, just slide it in and somehow it locks into place. If you think about how a drawer is, it's got like a little dip in the drawer, so when you push the drawer in, it like drops slightly, and that kind of like locks it in, and then if you lift it and tilt it a little bit, you can pull out the whole drawer. So we're trying to combine kind of the engineering behind a window and a drawer, and a door and a few other features all into one, which is pretty complicated. I would imagine this is probably the same type of thinking they do when they're designing a rocket, because you're taking pretty much the best of everything, you're combining it into one function. So anyways, that's kind of where we're at. It's going really well. But yeah, this is the direction we're going, and keep our fingers crossed and that it'll go exactly the way we're thinking, and I think it will. So, you're out. See you later.